Okay, I'm going to quickly go over your lab from yesterday and what you should have, the basics you should have gotten from it. So remember that station 1 was the primary station that I was concerned with as far as balanced and unbalanced forces, and that was just really remembering that in order to calculate net force, here you are subtracting forces. So 50 minus 50 is 0. That results, like in this picture here, no change of motion, there's no movement, and no winners. When the force is greater in one direction, then movement occurs in that direction, but not with the force of the full pulling. It is the forces that are opposing each other are subtracted, right? So remember on your test when you have opposing forces like the ones in this interactive, that you subtract. When you have forces that are going in the same direction, then that's when you add. When they're working together, you add them instead of subtract. But all these were working against each other, so you are subtracting. So that is the first station. And then we wanted to go on to our next station. See if I can move forward. There we go. So that was station 5 and 6. So we were skipping 2, 3, and 4. And this is where you were collecting the speed of the car. When you were recording your speed for the light car, that was 300 grams, you should have gotten about 0.85 seconds, so a little bit less than a second for each one of your trials, with an average of somewhere around 94 centimeters per second. And then for your heavy car, it should have been somewhere around 0.65 seconds, and an average then of 123 centimeters per second. So your heavy car was moving faster, definitely more velocity and more inertia in that heavier car. You could see how it was moving the entire ramp apparatus. When you created that graph, of course, you just needed to have a bar representing just your averages. You needed to have a decent scale, and then double check to make sure you had your labels and everything, but a pretty easy bar graph. There just should have been 2, one bar representing your light car and one representing the average speed of your heavy car. And then for this station, the first 2 questions we just covered the questions on. And then it asked you to watch this video and kind of think about it in comparison to your lab. So how does mass affect gravitational potential energy? The more mass something has, the more potential energy and inertia it has. Gravitational potential energy, of course, this is kind of a review of our old unit, was most at the top of the ramp, and kinetic energy was most towards the bottom of the ramp. And as it was going down the ramp, speed is associated, number 6, with kinetic energy. The heavy car had more inertia, so resistance to a change in motion. So it was heavy, harder to start and push. Hopefully you noticed it was more difficult to pull up the ramp, but it also would have been more difficult to stop the motion of that car. So as gravity pulls that car down the ramp, then it also not only would have gone faster, but would have traveled for a longer distance. So that was the thing that I wanted you to get from that. And also, when the forces were balanced, when you were holding it still at the top after it had moved to the bottom and the ramp had stopped the car, were examples of when the forces were balanced. And of course, when the car was in motion and changing speed and stopping and starting was when it was unbalanced. This was a quick video just reminding you that unbalanced forces are exemplified when something is changing acceleration, or when it's accelerating. So when it's decelerating or accelerating in physics, that's both referred to as acceleration. So when it's changing motion, changing direction, but when it's not changing motion because it's still, or when it is moving at a constant velocity, so constant speed, constant direction, then those are balanced forces. And so I summarized the video in the sentence that says, mine was kind of cut off at the bottom, but forces that are balanced result in no change in motion. These include constant velocity and no movement. Unbalanced forces result in a change in acceleration. So that was my 3-sentence summary. Hopefully you had something similar to that. And then finally, station 9, you're looking at, you should have identified which forces were balanced and unbalanced. So our balanced forces were an apple hanging from a tree, a lamp sitting on a desk, a moon orbiting the Earth at a constant speed. So notice that constant speed is listed here, and then a train moving at a constant speed. So remember, if the motion is described as motion at all, unless it's defined as constant speed or a steady speed, then it's going to be unbalanced. But because both of these were identified as being a constant speed, they're balanced forces. Over here, these are all describing motion, changes in motion, and there's no reference to any kind of balanced or steady or constant speeds. So the parachuter falling to the ground, the soccer ball after it was kicked, the car accelerating is that key unbalanced word there. Starting motion, and a skier coming down a mountain. So all of these are motion without that word constant or steady. So you know that those are going to be unbalanced forces. If it is not moving at all, or it is moving at a constant speed, then that's where you've got those balanced forces. Hopefully that was helpful. Study hard for your test tonight.